Thank you for joining in. This project is funded by the European Union Horizon program. Our webinar series Lessons Learned is a part of the Circ-uits project and contribute to the dissemination of our 3 years innovation action results. Please enjoy.
With the next pilot, the one of BOSCH. So, Karin, Maat, Achim, please. The floor is yours.
Okay, so let's start with this slide. My name is Achim from the BOSCH team. We are in the pilot 1. And let me start with a short introduction to our strategies that we applied to our pilot in the project. As the name Circ-uits comes from circularity, we tried to take most of the known circular pillars that are also known as the 9 R's into account. That means strategy 1 was or is the recycling. BOSCH is highly interested in recycled plastic. We need recycled plastic of high quality and without pollution in future more and more. And the target is therefore to focus on how to get the plastic out of the product back and achieve sufficient quality when recycling it. Strategy 2 is, of course, the reuse of the whole part or of components and to extend the lifetime of the product or at least only of semiconductors. Then strategy 3 is the remanufacturing or the repairing or the refurbishment, and this is the extension of the lifetime also of defect parts. And last strategy is to identify functional concepts, how our pilot can also be used outside its normal environment. And in our case, it is without the car. Yeah. And now I give the floor to Karin.
Yes, my name is Karin Sämann. I'm also part of the BOSCH team. And we first were thinking about what kind of product we go into the project. So what is the focus on? And we decided to go for a braking stability program ESP9. And why did we do so? Because it's already in the field since, please go back, 2017. We have we well know about processing data and material data, which are very important because it's a data-based project. We have a high experience on this project, and we also already do a serious remain and repair business. So we know a lot about repairing and remain for it. It's, as I said, available for data and samples. It is a high volume product which has a high impact on the market, and it includes a lot of very common and manufacturing technologies. So the best choice we thought. Achim?
Okay, yeah, now I proceed. So before coming to results and achievements from the implementation phase, let me give you a brief overview about our network in the Circ-uits project. We start with Office. With Office, we started to define a digital twin for our pilot, taking into account the possible repair process, the critical raw materials, and the product carbon footprint. And additional, we provide some samples. From BOSCH side, we call that cores for a KE-based selection method by camera. From Maras, we got the expertise in recycling electrical waste and exergy calculations. We applied our product to the Greta tool of SUBSI and achieved a usable comparison function for our pilot. And we asked Erion to improve our recycling possibilities. We collaborate with Polytechnico and automate the desoldering of components from the pilots on PCB level. Last but not least, we collected and created material and media for BESO for use in publications and educations. In the end, together with Office, DIN and SUBSI, we wrote a CWA with the topic repairability. And the promising low temperature solder paste from Alpha not suits well to our specification of the ESP, so this option was not further implemented. Now let's come to the implementation phase of the pilot. First of all, you can see in the middle of the slide a visual compilation of some activities during the implementation. Elementary in this phase was to create a complex data set that describes our pilot. It consists of all subcomponents, junctions and fasteners that are involved in assemble the product, but also to disassemble the product. It also consists of all relevant raw materials for each component up to PCB level and the energy consumption during production of the whole product. With this data set, our partners were able to calculate a product carbon footprint of 8.5 kilograms for this pilot. Firstly, we analyzed pilot 1 when its product lifetime ends. If we would get back our product from field, and if it is not usable anymore, we would send it to a dismantling plant for electronics. And then it is mainly copper that we can receive back from our product. But we learned also how we can enhance the recycling rate of materials, for example, in supporting previous dismantling and sorting steps by the product design. To be honest, our product often stays in the car also at the end of lifetime. This is clear. That means it will go to a big melting furnace to receive metal alloys. In this case, only 8.8% of alloys can be recovered, and the rest of the product more or less works like fuel in the melting process. The most important requirement for repair is our product. This also means that the identified critical raw materials that are deeply included in our product cannot be recovered so easy. Putting more focus on repair, remanufacturing and refurbishment is therefore reasonable. The most important requirement for repair is our product design that should be able to be disassembled and be reassembled again. Here we identified some blocking points in our pilot. Namely, this is the press fit junction between the housing and the PCB, as well as the laser plastic welding process that creates a non-reversible connection between cover and housing. We like to push the repairability of our product, and this begins already in the design phase of the product. A scoring that gives an answer for the designers as well as for customers how good a product is designed for repair is one part of the DIN norm EN 45554, and we applied this norm to our product and described together with Office the way how to come to the final repairability scoring. And we received a scoring of 3.83, and this we documented in the CWA that we wrote. And the calculation is very complex, we have to say, and highly influenced by subjective values. This is the reason why we felt not very comfortable with this norm, especially from manufacturer's point of view. The reuse of subcomponents is one way to keep most of the carbon footprint of the pilot in the loop. Together with Polytechnico, we started a feasibility study for reuse components from automotive electronics. We desoldered chips from old PCBs, assembled them to new products, and start a validation. That's all from implementation. Let's take a look to the new eco-design, Karin.
Yeah, after the implementation and get out the feedback, where are the, let me say, hotspots or the keys in our product, we applied eco-design Of course, we don't produce new samples, but we did that in a, let me say, a theoretical way and simulated with the new ideas, again, our product. And therefore, first of all, we applied, as Achim said, it's important for Bosch also to use recycled plastics. We applied the recycled plastic to the housing. Then we adjust the cover for a more easy opening. Currently, we have to saw it more or less. Then we theoretically removed the silicons for better recycling in the end. Then we added also a feature to get out the PCB a little bit more easy, let me say. And last but not least, this is not an eco design, but it is important for the learning curve. We evaluate everything down to components. Means we didn't do a calculation only for the whole product. We also asked for values about only the housing, only the PCB, only the components, to get a better feeling what is worth to keep for the future, or what is worth to go further with it. And with this, we applied, and then we came up with the evaluation. And this is the evaluation of the applied pilot. And we saw that when we're using a recycled material, the CO2 footprint decreases of 1.5%, because it's not the main material. It's plastic, it's only the housing. So this is why it is just 1.5%. The most critical raw materials, as Achim already said, is still the copper, and it's mostly focused in the solenoids. We have other critical materials, but when we search for it, then it really comes down to the PCB or even the single chip. So if we really want to recover critical materials, we need to go down to the chips. This is a very important knowledge. We can improve the alloy content by separating, and the values are, I think, impressive. So for the PCB, it's 10%, and for the solenoids, as I said, mostly copper, it can be increased to 23% just by dismantling, let me say. The reuse of the desoldered chips was fully validated and successful. So theoretically, we can reuse the chips. Yes, we can dissolve and reuse them. The repurpose is not as easy, because it's a security or a safety relevant pilot, and the software is encrypted, and also the variation of the software is very difficult. So each ESP has its own software, so you cannot just by applying a standard and then making a new product out of it. Regarding the repair, when we are applying again on the norm, our new design, the scoring increases to 4.18. But we also realized that this norm is not easy to apply and easy to compare. So this is why we also came up with a new repairing scoring, so new ideas which we wrote down in the CVA, which maybe make it a little bit more transparent to calculate. And with this new scoring, the repair. This was the scoring, and the second one we did is we tried to come out with a CO2 value for the repair. Means what is the saving when we repair our product, and the saving for our current repair for current product is 3.5%. This is also due to the fact that most of the products have a really long lifetime, so at the end they live longer than the car. And when we are applying the new eco design, the CO2 footprint decreases by 10%, because it is less energy and less complicated to repair it.
Thank you for watching this webinar episode. If you're as passionate about sustainability and innovation as we are, here's how you can get involved. Stay connected with us on our social media and website for the latest updates and insights from the Circ-uits project. Whether you're an individual or an organization, there are plenty of ways to contribute. Reach out to us to learn more about partnership opportunities, events, and initiatives.